Alright, how's it going there, Algebra 2C people? Here we are again. This is 7.3, video 3. And this is the last piece. There's only these two examples. There's not a lot more, but you know, when you look at it in total, it was 9 examples when all's said and done with this. So here we go. Now, the only thing different, these are division. So like video 1 was just how do you factor and simplify one fraction. Just deal with it. Video 2 was multiplying, which involved fraction times fraction. Still factoring, still simplifying. Now this is division. Now there's one step. And then these turn into video 2, part 2. Okay? We should know from previous classes, I think I've even said it in class before, and we've only, we're together for like a week. You don't divide fractions in math. So if you have a fraction divided by fraction, you are supposed to do fraction times reciprocal. So the very first thing that we will do, I'm going to do up here, I'm going to rewrite this as a multiplication question. Never mess with this fraction. Always flip the second. Reciprocal meaning flip the fraction. So, number 1, it'll be 7x over 2x minus 10 times x squared minus 11x plus 30 all over x squared plus 6x. Don't do any factoring, don't do any simplification until you've done that rewrite. It should be in multiplication form before you start doing any of that key work. Okay? So, next thing we're going to do, now see, that resembles video 2, part 2's questions. So now we're ready to factor anything we can in these two numerators and these two denominators, do what we can. Here we go. 7x is a single term called a monomial. Can't factor it. So it's just going to stay 7x. This denominator of 2x minus 10 has a greatest common factor of 2. I will pull a 2 out front, which leaves me x minus 5. And that's the end of the factoring. That x minus 5 is not anything special binomial. It's not difference of perfect squares. X and 5 aren't perfect squares. This part, that is what we have called, or I have called, a typical trinomial. It will break up as follows. X and x for the x squared. Now when I see multiplying to 30, I think 5 and 6. I could have also been thinking 3 and 10, 2 and 15. But 5 and 6 stand out. Now notice that that's negative and that's positive. That means these got to be minus minus. And 5 and 6 will do the job. If you check this distributive property out, one way gives you minus 6x, the other part gives you minus 5x. Minus 6 and minus 5 are minus 11x. And negative 5, negative 6 multiply negative negative to a positive 30. We're good. This denominator, that needs to factor for here. That has a greatest common factor of x. Not a number, but x. So if I factor x out of the square, I just have an x left and a 6 here. Now, let's be super careful. This is a multiplication. We talked about this before. When you multiply, top goes with top, bottom goes with bottom. We can just connect this and call it one big fraction. And before we start thinking reduce, make sure you make a very good note of where's all my multiplication. Multiply, multiply, multiply. Multiply, multiply, multiply. Those are the boundaries. Those are areas I can reduce top to bottom. Now, as I'm looking here, the first thing that catches my eye, there is an x right here that can reduce with that x right there. And then the only other thing I see is this group x minus 5 with this x minus 5. Be super, excuse me, be super careful here, folks. Those aren't the same. They're similar, but we're not playing the similar game here. It's either same or not. So basically everything that's left over, and by the way, the 7 and the 2, they don't reduce with each other. Whatever's left over, that's the final answer. So here we go. We will be writing the final answer as 7 quantity x minus 6 over 2 quantity x plus 6. And that's that. Nothing else can be reduced. Again, don't think about saying, hey, those x's, if they're touching a plus or a minus, they're off limits. It's got to be all multiplication separation to do the reducing. All right, so there's example 8. There's the division. You can see as soon as you got past that first step of changing this to times and flip, reciprocal, just like video 2, just like part 2. Now, one final example over here, guys. And it's not like, well, okay, we get division means times reciprocal. I wanted to address this situation because this one doesn't look like it's fraction divided by, and this doesn't look like a fraction. Well, guess what? Anything looks like a fraction if you put it over 1. So, still step number 1. If you have anything involving a fraction in division, the very first thing is multiply reciprocal. That's what you do. So we're going to be looking at 6x squared plus x minus 15 over 4x squared times flip 1 over 3x plus 5. And that's going to stay in parentheses for right now. We'll talk about that in a second. It's a group right now. We'll talk about it anyway. Next, now that I have this times reciprocal, now that it's in multiply form, that's where you do things. I try to factor anything I can. This numerator, so kind of saved it till the last example 9, this has got the most difficult factoring we've had in terms of, like, we have a number here, 6. All the other trinomial factorings have been like this type, which is basic. X squared leads off as basic. First thing that comes to mind when I think of this factoring, it's still the trinomial look, x squared, then an x, then a number. So I'm still going this route. I'm going to go with 3x and 2x. Now that's not guaranteed that it's going to work, because it could also be 6x times 1x, but I'm going to start here. And when I think of 15, I think of 5 times 3. Now, I am limited here. I can't put 3 times 5. The 3 can't go here, because if it was 3 and 3, this would have a greatest common factor in it. The original doesn't have a greatest common factor. So the 3 can't go there. If this is going to work, this has to be 5, and this has to be 3. And then, now that's negative 15, so one of these has to be negative and one of these has to be positive. If I check that, now remember, I know that 3x times 2x is 6x squared. I also know that negative 5 times 3 is negative 15, but what about this? That's a 1x. So I have to make sure the rest of the distributive property, see, I only checked the 3x and the 2x and the negative 5 and the 3. What about 3x times 3? That's positive 9x. Minus 5 times 2, that's negative 10x. Note, I had a positive 9 and a minus 10. 9 minus 10, that's negative 1. That doesn't say negative. That says plus. That means my signs need to switch. That's a plus. That's a minus. This gives me negative 9x. This gives me plus 10x. Negative 9 plus 10 is 1x. There's the right factoring. The 4x squared, that's a single term. No plus minuses, doesn't factor, not even on the table. Times. 1 goes there. 1 obviously doesn't factor. And for the record, 3x plus 5. Does not factor either. That does not have a greatest common factor in it. It can't be a thing like difference of squares. It's not even a difference. It's a plus, so it's not difference. It's not subtraction. So again, I'm going to put this back in parentheses because it didn't factor. Now I want to talk groups and anything I can reduce. Now, when it's times, it's one fraction. Remember? All top, all bottom. My multiplication symbols are here and here, between the 4 and the x squared, here between here, and that's it. That's it. There's not a lot this time. And I reduce what I can. Well, what I can see right now is 3x plus 5, 3x plus 5, top and bottom. After that, I don't see anything. The top just has 2x minus 3 times 1, of course, is still 2x minus 3, and the bottom's got 4x squared. And that's it, people. There is not a spot to reduce this, and even if you're looking to say, well, what about this x and this x? This group, this 2x is attached to minus, can't reduce. Nothing in this is reduce eligible unless the entire thing, 2x minus 3, reduced. Well, the entire thing doesn't. So it's stuck. There's your final answer. So you guys, that completes section 7.3. I just wanted to do it in small little spurts so that you can kind of look at each type and then direct maybe deal with that part of the assignment. So, you just do the single fraction simplify, the two fractions multiplied, the two fractions division. There's your video 1, 2, and 3. So you can just kind of do it in small amounts. Okay? So that is going to be conclude this week's work. It's really just one big assignment, but I wanted to break the videos down very carefully because I knew there'd be 8 or 9 examples. So that's it. Thanks for tuning in, guys. We'll see you next time.